Welcome, everybody. This is section 3.7 on polynomial inequalities. The essential question for today is how do we solve a polynomial and rational inequality? So it's essentially with the polynomial inequalities, it's essentially the stuff that we've been doing, right? We've been solving for the polynomial, solving the zeros, and graphing them, finding the y-intercept and graphing them. Okay, we're going to do the same thing. We're going to treat it like an equation, but at the very end, we're going to fulfill that inequality. Okay, with rational inequalities, it's going to be a totally separate thing. So here we go, and we'll do we'll do 4 examples. Okay, so here we go. These are the steps to solving polynomial inequalities. We're going to move all the terms to one side of the equation. So essentially just making one side equal to 0. Okay, just like how we would in terms of solving for a polynomial equation. And then we're gonna factor the polynomial, getting our real zeros. Just the same steps as a polynomial equation. And then we're gonna graph. Okay, steps 3 and 4. You guys can make a table or a diagram based off of the values that you get, the real zeros that you get. But the easier step for this one would just be to graph. And then step 5 would just be to solve it, right? Just to think about what values would satisfy our inequality. Okay, so our first example is here. And I also got it here on our document camera. Okay, so this is the example that we're going to cover today. So it's 2x cubed plus x squared plus 6 is greater than or equal to 13x. Okay, so our first step is to make one side equal to 0 or to move all the terms to one side of the equation. So I'm going to subtract 13x from both sides of the equation. Okay, so then this would make this one 2x cubed plus x squared minus 13x plus 6 is greater than or equal to 0. Right? And here we would just solve it just normally, how we would in previous sections, right? We got to find our APRR, right? All possible rational roots. It's going to be the factors of 6 over the factors of 2. The factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 over plus or minus 1 and plus or minus 2. Right? So my list would be plus or 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1 would be 1 plus or minus 2 plus or minus 3 or plus or minus 6. And then 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1, which we got here. 3 divided by 2 would be plus or minus 3/2. And then 6 divided by 2 would be 3, which we got here. Right? So these numbers here are my all possible rational roots. Okay? Using those numbers, I'm going to use synthetic division to fish for a root. So 2, 1, negative 13, and positive 6. And here, this 13 kind of is misplaced. So I'm not going to use 1. I'm not going to test out positive or negative 1. I'm going to test out 2. So 2 comes down. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. Negative 13 plus 10 is negative 3. 2 times negative 3 is negative 6. And then we get a 0. Right? So that's one of my zeros. So since 2 is a root, then x minus 2 is the factor. And we have 2x squared plus 5x minus 3. Right? And here, since it's x squared, I'm just going to factor it out. Can I get two numbers that multiplies to negative 6 and gets me a sum of 5? Two numbers that multiplies to negative 6 and a sum of 5. 6 and negative 1? Yes. So positive 6x minus 1x. Okay. Grouping the first two and the next two, what's in common between this guy, 2x squared plus 6x, is a 2x. What's left over is x plus 3. And then since there's a negative in the front here, I'm going to take that out. There's nothing in common between the x and the 3, so I just took out a negative. So that'll be a positive x plus 3, right? And then here, I'm going to gather the x plus 3's. What's left over is this 2x minus 1. Correct? So that's how you would factor out 2x squared plus 5x minus 3. And then this x minus 2 just kind of drops down with it. Okay? The original question was greater than or equal to 0. But in order to find my zeros, I'm going to set each of them equal to 0. And then solve for x. That's positive 1/2 at the tail end. So I got my zeros. Zeros lie at 2, negative 3, and 1/2. And they all have a multiplicity of 1. Okay? They all would have a multiplicity of 1. Okay? So just remember that when you are graphing, because the next step is to graph it. Okay? If you look at the top, my y-intercept is 6. Okay? So my y-intercept is 6. I have my x-intercepts here, and let's go ahead and graph it. Okay? When we graph, yeah.
How do you know the y-intercept is 6?
Because up here, my x is all equal to 0. So if I plug in 0 here, this would be 0, this would be 0, this would be 0, and just leave it at that. Yeah. So 2, 4, 6. That's my y-intercept. 1, 2. That's 2. Here will be 1/2. And then 1, 2, 3. That would be my other x-intercept. And now if you look at the original question, the degree is 3 and it's positive. So it's a positive odd degree. So my end behavior is positive odd, which would look like what? Down, up, right? That would be my end behavior. And then going from left to right, starting off at my negative end behavior, right? As x approaches negative infinity, you would go towards the -3, cut it because it has a multiplicity of 1, go through it, hit 6, come back down to 1/2. You would go through it, come back up to 2, go through it, and then go to my end behavior, right? So essentially, that's just the way that we graph this. So now if I look at this equation, I want this whole thing, we would have graphed, to be greater than or equal to 0, right? If it's greater than or equal to 0, then I'm interested in this part here and this part here, right? Yeah? Does that make sense? And so what is that part in terms of interval notation? This is -3, this is positive 1/2. So it goes from -3 to 1/2, and it's bracketed. Why is it bracketed? Why do I have brackets for this equation here? Because it includes 0, right? Because it's greater than or equal to 0. Union, because there's two intervals, 2 to infinity. Parentheses, brackets around the 2. Yes.
On a test, what would the question look like where we have like do this? Just ask
Like this?
what are the intervals of the? It would just be an equation.
Yeah. Yeah.
So the answer would be that final thing.
This would be your solution. Yeah. Okay. All right. Cool. I have another one here. Another example of a polynomial equation, which is a little bit difficult, more difficult because it's x to the fourth. Okay. Know that x to the fourth, we're gonna end up testing it twice, right? So we're gonna make one side equal to 0 again. So I'm gonna subtract 2x cubed and subtract 12x, subtract 2x cubed and subtract 12x from both sides. And we have 3x to the fourth minus 2x cubed minus x squared minus 12x minus 4 is less than 0. Right? So we got that. We're good to go. Now we got to use our APRR again, right? All possible rational roots. Factors of -4 over the factors of 3. Okay? Factors of -4 are plus or minus 1, plus or minus 2, and plus or minus 4. Over factors of 3 are plus or minus 1 and plus or minus 3. Right? So we have plus or minus 1, plus or minus 2, plus or minus 4, because if they're all divided by plus or minus 1 here, it's just the same list. And then dividing it by 3, we have plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. And hopefully we don't have to use that list. Okay? So we got that list and APRR this by synthetic division. So 3, -2, -1, -12, and -4. Okay. I'm gonna bypass 1 again. I'm gonna go to 2 because this 12, right? So drop down to 3. 3 times 2 is 6. -2 plus 6, that's 4. 2 times 4, that's 8. -1 plus 8, that's 7. 2 times 7 is 14. -12 plus 14 is 2. 2 times 2 is 4. That makes a 0. Right? So now I have x minus 2 from here to 2. And then 3x to the third plus 4x plus 7 plus, or 7x, 4x squared plus 7x plus 2. Correct? So I'll have to do this over again. So to figure out my APRR, I'm going to get the factors of 2 over the factors of 3. So that's plus or minus 1, comma, plus or minus 2 over plus or minus 1, plus or minus 3. So I have plus or minus 1, plus or minus 2, plus or minus 2, and then plus or minus 1/3, and plus or minus 2/3. Right? So fish correctly and efficiently. Okay. Looking at this, the coefficients of this 3, 4, 7, and 2. What do I need? A negative, right? So I'm going to bypass all the positives. So I would need a negative somewhere just so that I can subtract numbers. And if it's a positive 2, I need to subtract by 2, right? Yeah, so I need a negative somewhere. So I'm going to try a -1. So 3, negative, -3, 1, -1, 6. That's not going to work. Yeah, -2. Now that I've done this more than once, I'm going to highlight this row just so that my eyes go there. So drop down to 3, -6, right? -6, yeah. -2, +4. That's not going to work because that's 11. Okay. -1/3. Let's try that. Okay, remember with 1/3, we want multiples of 3 here. Okay, so this 3 would drop down. 3 times -1/3 is -1. 4 minus 1, that is 3. Again, I have a -1. I'm going to have 6. -1/3 times 6, that would be -2. And then we get a factor of 0, right? A remainder of 0. Okay. So now I have what do I have? X minus 2 times 3x plus 1, turning the -1/3 into a factor is 3x plus 1 times 3x squared plus 3x plus 6, or yeah, plus 6. So 3x squared plus 3x plus 6, I can take out a 3. X minus 2, 3x plus 1, and I would have an x squared plus x plus 2, right? Now, can I factor out the x squared plus x plus 2? Can I factor that? I already see a head shake of no. No, right? There are no two numbers that multiplies to 2 and gets me a sum of 1. Yeah. So since there are no numbers, let's just move on from here. It equals 0 then. So x minus 2 equals 0. 3x plus 1 equals 0. And x squared plus x plus 2 equals 0. Right? Here we would have x equals 2. Here we would have x equals negative 1/3. Here, I'm going to have to use my quadratic function or quadratic formula. X equals negative b, which is 1, plus or minus square root of b squared minus 4 times 1 times 6 AC, 4 AC, all over 2 times 1, right? 2a. Okay? Simplifying this out, we have negative 1 plus or minus the square root of 1 minus 8 over 2. Negative 1 plus or minus, yes. Oh, it should have been a 2. Huh. I apologize. 4 times 2 is 8. Yeah. Or 4 times 6 should have been 24. Okay. Square root of negative 7 over 2. So this would be negative 1 plus or minus I square root of 7 over 2, right? Okay, that's my 0 there. But since that is imaginary, we do not need to do anything when we're graphing. We're just going to be graphing these two zeros, this one and this one. Okay? Questions so far? No? My y-intercept, if you look at the original, y-intercept would be at negative 4. So keep that in mind. All right, as we start graphing. So when we graph, just create some lines. Okay. This one, it's a positive even degree. If it's a positive even degree, what's my end behavior? Up and up. Okay. 1, 2. This would be 2. And this is 1/3, negative 1/3. Okay. And then my y-intercept is 2, 4. Yeah, it would be negative 4. Okay. And then I will start with my negative end behavior. I would come down to the 1/3, go through it because that's a multiplicity of 1, come down to the 4 or the negative 4, my y-intercept. I know I'm gonna have to eventually come back up to 2 and then go to my end behavior. Okay. So that's my graph, and I am interested. What am I interested in? Things that are less than 0, right? Right here. Things that are less than 0. So what's less than 0 on this graph is right here, right? So then that would be negative 1/3, comma 2, and they're both parentheses because it's just less than. Okay? Cool? Questions? No? So these are the steps to solving a rational inequality. And the only difference between rational and polynomial inequalities is the way that we solve it. And the zeros and the cut points, quote unquote cut points in number 2. Okay, we're going to factor everything. Okay, we're going to move all the terms to one side of the equation, factor everything out, and then determine the cut points. Cut points are meaning like what makes this rational function either 0 or undefined. Okay, and then we're going to list the, and then we're going to make a table. Okay, so I have the example that we are going to do, this one here again on my, oops, here again on my document camera. There we go. Okay, so we're going to make one side equal to 0 first. So here I'm going to subtract by 1. Okay, making this 1 minus 2x over x squared minus 2x minus 3 minus 1 is greater than or equal to 0, right? Now this minus 1, I have to put it in this fraction, essentially. So I have to get my common denominator. What is my common denominator? Between over 1, between 1 and x squared minus 2x minus 3. This thing, right? Yeah. So remember that 1 equals x squared minus 2x minus 3 over x squared minus 2x minus 3. Okay? Yeah, 1 equals that, right? So on the top here in my numerator, I'm going to have 1 minus 2x minus x squared minus 2x minus 3 all over x squared minus 2x minus 3. Okay? Does that make sense? What we just did is greater than or equal to 0. Okay? Does that make sense, class? Yeah. I'm going to clean up. Yes. Why is this minus? Yeah. Because it's minus 1. Yeah. Yeah. Okay. Now I'm going to clean up the top by distributing out that negative and gathering the like terms. So that's 1 minus 2x minus x squared plus 2x plus 3. Right? Gathering the like terms. Negative x squared. These two guys would cancel out. And I have 1 plus 3, which is plus 4. Right? All over x squared minus 2x minus 3 is greater than or equal to 0. Right? Yes.
Where do we canceling from? Like,
How do we cancel?
yeah, what are we canceling from? Like,
I just negative 2x plus 2x, that's a 0. Yeah, they cancel out. Okay? Since this is a minus class, I'm going to flip this. Okay? So it's 4 minus x squared over x squared minus 2x minus 3 greater than or equal to 0. Right? Now, factor the top and factor the bottom. How do I factor the top? What does that break out to be? You guys remember? Yeah. Not 4. 2. 2 plus x times 2 minus x. 4 minus x squared, that's a difference of squares. This is a perfect square. 4 is a perfect square. X squared is a perfect square. And there's a minus sign between them. So it breaks out to be a plus b and a minus b. Okay, over This one is easy to factor. The denominator, x and x, this will be minus 3 and plus 1, right? Is greater than or equal to 0. Okay? Now I have to make every single factor here equal to 0. Because if one of these factors are 0 on the top, that makes this whole thing 0, right? If one of these numbers here, the negative x minus 3 or x plus 1 is equal to 0, it makes this whole thing undefined. That makes sense? Yeah? So I don't want either. I want the 0 because it's greater than or equal to 0, but I don't want this to ever be undefined. Okay, so you have to get basically 4 cut points. Okay, the 4 cut points, if I make 2 plus x equal to 0, that would be negative 2, right? 2 minus x equal to 0, that would be positive 2, because 2 plus 2 is 0. X minus 3 equal to 0, that will be 3. And then x plus 1 equal to 0, that will be negative 1. Right? So these 4 points are my cut points. Okay? So now if I make it into like a number line, remember this number line that we did? At negative 2, let's make this negative 1, make this 2, and make this 3, right? I know if it's x equals negative 2, then I know this one becomes a big fat 0. If x is negative 1, that becomes undefined. If x is 2, that becomes 0. If x is 3, this becomes undefined, right? But again, I want to know what's going on with in between these cut points, okay? So this fun chart appears. One, two, okay. 1, 2, 3, 4, and then so every little step here, I'm just gonna put one of these factors. Okay, a 2 plus x, 2 minus x, x minus 3, and an x plus 1, right? Here are all the factors to it. And then on the bottom here, I'm just gonna put the whole thing. 2 plus x times 2 minus x over x minus 3 times x plus. Okay. Getting my test points. Remember my test points? So here, one number that will represent this whole interval would be negative 3. A number that represents this whole interval would be like negative 1.5. Let me just put it on top. Representing this interval would be 0. Representing this interval would be 2.5. Representing this interval would be 4. Okay, I just picked a point. Pick a test point. Right? 2 plus negative 3, that's a negative number. 2 minus negative 3, that's a positive number. negative 3 minus 3, that's a negative number. Negative 3 plus 1, that's a negative number, right? So these two are multiplied. So negative times a positive is a negative over negative times a negative is a positive. So this becomes a negative. Yeah.
What are we like adding exactly?
The negative 3.
The -3 with
2 minus negative 3.
Okay.
Will be a negative number.
Oh, you put the x.
2 minus whatever your test point is. That's what we're returning x to. Okay. So once you do that, I just care about the positives and negatives. I don't care about the value. Okay. So that becomes a negative number. 2 plus negative 1.5, that's a positive number. 2 minus negative 1.5, that's a positive number. Negative 1.5 minus 3, that's a negative number. Negative 1.5 plus 1, that's a negative number. So a positive divided by or times a positive is a positive, divided by negative times a negative is a positive. Positive divided by a positive is a positive. Right? Okay. Doing the same thing with 0. Positive, positive, negative, positive, 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 negative, positive. Right? Just plugging in 0. So a positive times a positive is a positive. A negative times a positive is a negative. So a positive divided by a negative is a negative. Okay? Doing the same thing with 2.5. 2 plus 2.5 is a positive. 2 minus 2.5, that's a positive. 2.5 minus 3, that's a negative. 2.5 plus 1, that's a positive. Right? So we got positive times a positive, which is a positive, divided by negative divided by or times a positive, which is a negative. So that would be a negative. Yeah. 2 minus 2.5. This would be a negative. Right? Thank you. Thank you. Yeah. So this part would be a negative as well, right? A negative divided by a negative is a positive. Okay? 2 minus 2.5 is a negative. Yes. 2 plus 4, that's a positive. 2 minus 4, that's a negative. 4 minus 3, that's a positive. 4 plus 1, that's a positive. So positive times a positive is a negative. Or positive times a negative is a negative. Positive times a positive is a positive, which would turn this into a negative. Right? Apologize if there's any confusion here on my part. So what am I interested in? If I look back at our original question, it's greater than or equal to 0, right? So if it's greater than or equal to 0, I want positives, which would be here and here. Okay? Is that whole equation is greater than or equal to 0. Okay? So it's 2 minus x times 2 plus x over x minus 3 times x plus 1 is greater than or equal to 0, right? Which we got from -2 to -1. Let me just write that down. And union 2, comma 3, like that, right? These numbers represent the start and the finish. Yeah, the start and the end of the intervals. Okay? Now you have to be careful of your brackets and your parentheses. Just because it's equal to, they're not all brackets. Because if it equals -1, that's undefined, right? And if it equals 3, that's also undefined. So these 2 points at -1 and 3 need to stay parentheses. Okay, at -1 parentheses, at 3 parentheses. Now, since they're equal to 0, these guys become brackets. 2 and -2. That make sense? Yeah.
Where do we get the 2 and negative? I'd like the -1.
Right here. All these points.
Aren't they,
So in between these two numbers of -2 and -1, they're positive.
That's it.
Yeah. Yeah. Okay. So then this here is my solution. Yes. If my denominator is 0, it'll be undefined. Yeah. Okay. All right. Cool. Questions on the process? No? Just factor, make sure your denominator stays undefined, your numerator stays at 0, and just work the chart. All right. We are done for today, class, and that is the lesson for 3.7.